In this section, we will talk about the tangent line and instantaneous rate of change, whereas in the previous section, we talked about the average rate of change. First, let's talk about the difference between a secant line and a tangent line. A secant line is a line that goes through a graph like this. And in the previous section, what we did was we took the average rate of change between 2 points. On the other hand, a tangent line is a line that just barely touches the graph at a particular point. Okay, let me repeat that. A tangent line is a line that barely touches a graph at a particular point without going through it. So just to give you another example, this would be a secant line because it goes through the graph. However, if I were to take this point and if I were to draw a line that barely touches this graph at that point, then this would be a tangent line. So this line here, this is another tangent line to the graph at this particular point. So once again, a tangent line at any given point barely touches the graph without going through it, and a secant line goes through the graph. Okay, so let's talk about the instantaneous rate of change. The instantaneous rate of change of f of x at point x is the slope of the tangent line at the point x comma f of x. So I'm going to repeat this over and over again. The instantaneous rate of change is the slope of the tangent line at the point x comma f of x. So what is a tangent line? It's this line that barely touches the graph at a particular point. That's a tangent line. And what is the instantaneous rate of change? The instantaneous rate of change is the slope of that tangent line at the point x comma f of x. Another notation for that is f prime of x. So f prime of x, this is the slope of the tangent line at the point x comma f of x. So in your mind, automatically now, start associating f prime of x as instantaneous rate of change, which is the slope of the tangent line at the point x comma f of x. F prime of x equals to slope of the tangent line. Here's an example. Estimate the instantaneous rate of change, in other words, f prime, at the point x equals 1. So what's the instantaneous rate of change? It's the slope of the tangent line. So to find the instantaneous rate of change, we take the point x equals 1 and you find the corresponding point on the graph. And we want to draw a tangent line. Now this is going to be a rough estimate. So our tangent line, remember, it's going to barely touch the graph, so it's going to look something like this. Okay, this will be the tangent line at the point x equals to 1, and the corresponding y value is 4. So this point is 1, 4, and the tangent line is barely going to touch that point without crossing the graph. We want to estimate the slope of this line. Well, to get slope, we need two different points. So one point we're given. The first point is a point 1, 4, but we need a second point to estimate the slope. So just because this is an estimation, we can take this point right there, which seems to be the point x equals 2 and y equals 9. So we have our 2 points. We can use those to find the slope of the tangent line, which is the instantaneous rate of change. So the slope is y2 minus y1, which is 9 minus 4, over x2 minus x1, which is 2 minus 1. This is equal to 5 over 1, which is 5. So the instantaneous rate of change, which is now the keyword instantaneous, this refers to a single point and the tangent at that point. So the slope of the tangent line at the point 1, 4 is equal to 5. Okay, let's find the slope of the tangent line at the point x equals 2. So let me change the color here. We're looking at x equals to 2. The corresponding y value on the graph is going to be this one, which is the point 2, 11. So we have 1 point. Our first point is 211. But the instantaneous rate of change refers to the slope of the tangent line. So now we got to draw the tangent line at this point. And again, this is going to be a rough estimation. So the tangent line will look something like this. Okay, again, it's a very rough estimation. So our second point we can pick as this one. We want to pick something that's, like on the corner of an intersection of an x and a y. So this point seems to be the point 3, comma 19. So we got 2, comma 11 and 3, comma 19. So the instantaneous rate of change, or the slope at the point 2, comma 11 is y2 minus y1, which is 19 minus 11, over x2 minus x1, which is 3 minus 2. This is 8 over 1. In other words, this equals to 8. So notice that at x equals 1, the slope, the instantaneous rate of change of the tangent line is 5. At x equals 2, the slope of the tangent line is 8. So it seems like the slopes are increasing as the x values get bigger. Okay, here's a definition of the instantaneous rate of change. The definition is as follows. The instantaneous rate of change, or the slope of the tangent line at the point x comma f of x, is given by this: the limit as h approaches 0 of f of x plus h minus f of x over h. This should look very familiar because this is the difference quotient which we practiced in chapter R. So let's find the instantaneous rate of change of h of x equals to 4x squared plus 3 at the point x equals to 3. So for this, we have to apply the definition, which is as follows. It's the limit as h approaches 0. That's always going to be the same. So the x value has nothing to do with that. It's always limit as h approaches 0 of f of x plus h minus f of x all over h. So we know what f of x is. In this case, it's h, but h of x is equal to 4x squared plus 3. What we really need is this first term, right? So we want to find out what is h of x plus h. So this becomes your input. We practiced the difference coefficient earlier. So we take our input and we replace the x value with this input. So we're going to have 4 times x plus h squared plus 3. If we simplify this, this will give us 4 times x plus h times x plus h, which is x plus h squared, plus 3. So this equals to 4 times x squared plus xh plus another xh plus h squared, and then we got plus 3. Then we distribute the 4, so this is 4x squared plus 4xh plus 4xh plus 4h squared, and then you got the plus 3 on the outside. So the 4 is distributing to all of these terms. Then we combine our like terms. So we're going to get 4x to the second power plus 8xh plus 4h squared plus 3. So this whole thing is equal to this part, the x plus h part. Now, the instantaneous rate of change is given by this definition. The instantaneous rate of change, which is the slope, which is why we have m, of the tangent line is equal to limit as h approaches 0, that's never going to change, of f of x plus h, which in this case is this whole quantity, which is 4x to the second power plus 8xh plus 4h squared plus 3, minus f of x, which is 4x squared plus 3, all divided by h. Now let's combine our like terms. We have a 4x squared and a negative 4x squared, so that is going to be 0. We have a positive 3 and a negative 3. That is going to be 0. So what are we left with? We're left with the slope m equals to the limit as h approaches 0 of 8xh plus 4h to the second power, all divided by h. And remember, we talked about how in the difference quotient and in the second to last step, we should have all the terms without the h canceled out. So we should only have terms with the h left over at the end. And now if you simplify this, we're going to be left with m equals to limit as h approaches 0. The h divided by h is 1, so 8x plus 4h squared over h. This is going to be 4h. Now here's what else we know. We know that x equals to 3, and we know that h is approaching infinity. So if I simplify this, the value of x is equal to 3, and we know that h is approaching 0. So I replace x with 3, I replace h with 0, which gives me 24 plus 0, or 24. So the slope of the tangent line to the curve 4x squared plus 3 at x equals 3 is 24. Okay, so let's take a look at another example. We want to find f prime of x. Remember, f prime of x is same thing as the slope of the tangent line at the point x comma f of x. They're interchangeable. So find f prime of x, which is the slope of the line at x equals 3. In other words, what is f prime of 3? So for that, we need the following. We need the limit as h approaches 0 of f of x plus h minus f of x all over h. All right, so this time I want to go a little bit more quickly. First, I want to find f of x plus h, which is going to be 9 times x plus h to the second power minus 4 times x plus h plus 1. I replace each of the x values with the input, which is x plus h. So this gives me 9 times x squared plus 2xh plus h squared minus 4 times x plus h plus 1. If I distribute the 9, I get 9x squared plus 18xh plus 9h to the second power minus 4x minus 4h minus 1. So this whole thing is equal to f of x plus h. Now what do we need? We need to plug it all into this limit. So we have the limit as h approaches 0, that never changes, for the instantaneous rate of change, or f prime of x, which is also called the derivative. They're all the same thing, so we have to know all the different names for it, and we'll review that in class. Of this whole thing, which is 9x to the second power plus 18xh plus 9h squared, and I'm running out of room, minus 4x minus 4h minus 1. All of that is going to be minus f of x, which is 9x squared minus 4x plus 1. Sorry about the lack of room. And then and then all of that is divided by h. So 9x squared minus 9x squared is 0. We have a negative 4x minus negative 4x, that's 0. Negative 1 minus negative 1, that's 0. So what are we left with? We're left with limit as h approaches 0 of 18xh over h plus 9h squared over h. And then we have this thing too, which is the minus 4h over h. So this is limit as h approaches 0 of 18x plus 9h, because these reduce to h, and then minus 4. Lastly, the value of x is 3, and h is approaching 0. So we have 18 times 3 plus 9 times 0 minus 4. So 18 times 3 is 54. I don't know why that keeps happening. 9 times 0 is 0, and 54 minus 4, this is equal to 50. So all that work, which means the slope of the tangent line at x equals 3 is equal to 50. This is also called the derivative. It's called the instantaneous rate of change, which is the slope of the tangent line at the point x equals 3, and it's also f prime of 3.